A frame house is one of the fastest to build. With proper organization of the process, it can be erected in 10 days. The main advantage is the minimal time required for settling and drying of materials. Standard construction is delayed due to the lengthy preparation of the site, waiting, drying of the foundation, errors in assembling the frame and installation of the roof, as well as the lack of coordination between different crews. The main rule is to prepare all materials and tools in advance. The delivery of building materials is ordered at least a week before the start of work. Allocate 1 to 2 days for the foundation, 3 days for the frame, 1 day for the roof, and for insulation and finishing. The remaining 5 days. The simpler the project, the faster the construction. A single-story house with an area of up to 800 square feet is built faster than a 2-story one. The optimal option is a rectangular shape without complex architectural solutions. Minimal partitions, standard window and door sizes, a pitched roof without complex joints. The frame technology allows for starting interior finishing immediately after the walls are erected. Since the house does not require time for settling, however, mistakes at each stage can slow down the process. If the foundation is chosen incorrectly, misalignments will begin. If errors are made during the frame assembly, the walls will bear additional load, leading to cracks and deformation. If the house is insulated incorrectly, cold bridges will appear, reducing energy efficiency. All processes must proceed according to schedule, without downtime. Site preparation begins a day before the official start of construction. Materials are delivered in advance to avoid delays. Work is carried out in strict order. First marking, then foundation, frame, roofing, insulation, exterior and interior finishing. Each stage is allocated a specific time, and it cannot be deviated from. Let's start with the first step of site preparation. Site preparation. Before construction, it's important to choose the right location for the house. A mistake at this stage will lead to problems with the foundation, drainage, and building operation. First of all, the type of soil is assessed. If it is clay, drainage needs to be considered, otherwise the foundation may heave. If it is sandy, a wider base will be required to avoid settling. If the site is marshy, it's better to immediately opt for a pile foundation instead of a strip foundation. You can check the soil by digging a hole 3 feet deep. If water appears at this level, it means there is a high groundwater level and waterproofing will be required. After analyzing the soil, the site is marked out. It's optimal to orient the house so that the facade faces south. This will provide natural lighting and reduce heating costs. The site is cleared of trees, shrubs, stones, and debris. The top layer of soil is removed to prevent plants from growing under the foundation. If there is a slope, it is leveled or a basement floor is planned right away. Then temporary access roads are prepared for the delivery of building materials. If this is not done, the equipment will get stuck in the mud, which will delay construction. Temporary electricity and water are a must. Without this, work will slow down as time will be spent transporting water and finding a power source for electric tools. Once the site is prepared, you can start on the foundation. Foundation. The choice of foundation depends on the soil, budget, and construction timelines. The fastest option is a screw pile foundation. The piles are screwed in within 1 day, after which you can immediately install the binding. This type of foundation is suitable for most soils, except rocky ones. Its downside is the need for precise load calculation and additional floor insulation. An alternative is a slab foundation. It is poured in 1 day, and construction can begin in 2 days. It distributes the load evenly, making it ideal for sandy and weak soils. However, it requires more concrete and reinforcement, which increases the cost. Strip foundations are used less often because they require time to set. If choosing this option, it's better to make it shallow and insulated with polystyrene foam. This will reduce the impact of frost heave and allow construction to begin 3 days after pouring. Before pouring any foundation, a sand and gravel cushion 8 to 12 inches thick is made. It distributes the load and prevents settling. The reinforcement frame is tied in advance to save time on the construction site. When pouring, it's important to eliminate voids. To do this, the concrete is compacted with a vibrator. Waterproofing is mandatory, otherwise moisture will penetrate the foundation and eventually destroy it. After pouring the foundation, utilities are immediately laid, including water supply, sewage, and electricity. If this is not done at this stage, you'll have to chisel the concrete later, which will complicate and slow down the work. As soon as the foundation is ready, you can start on the framework. By the way, if you suddenly need to quickly build an office, warehouse, or even a house, contact the professionals from the Production Association. System. This is a leading manufacturing enterprise offering a full range of work and services from designing modular buildings and houses for various purposes, of any complexity, to developing design projects, including interior finishing. The guys provide a guarantee for their work, which is very important these days. Erecting the framework. The framework is the foundation of the house, and it is assembled with maximum precision, without any distortions. They use dry calibrated wood with a moisture content not exceeding 20%. If you use raw boards, they will warp the framework as they dry. The minimum cross-section of the studs is 2 by 4 inches. In northern regions, it's better to use 2 by 6. The spacing of the studs is usually 16 inches. This is optimal for wall strength and ease of insulation. The framework is assembled on a flat surface and raised in ready-made sections. This saves time and reduces the risk of errors. The bottom plate is made from boards treated with antiseptic to protect against moisture. It is attached to the foundation with anchors. Corners are reinforced with metal brackets or braces, otherwise the frame may tilt under load. The first floor joists are made from 2 by 10 or 2 by 12 boards with a spacing of 12 to 16 inches to prevent the floor from sagging. A subfloor is immediately laid between the joists to facilitate convenient work. As soon as the walls are assembled, the top plate and ceiling joists are immediately installed. If the house is single-story, the top plate should be double to ensure the rigidity of the structure. If it is two-story, the ceiling joists are laid with a spacing of no more than 16 inches, otherwise the floor will vibrate when walking. The frame is ready. Now it needs to be protected from precipitation as quickly as possible to prevent moisture from being absorbed into the wood. The next stage is the roof. Roof installation. After assembling the frame, they immediately proceed to the roof installation. The faster the house is covered, the less chance there is for the wood to absorb moisture. A gable roof design is usually used. It is simple, strong, and suitable for most regions. The main materials for the rafters are boards measuring 2 by 6 or 2 by 8 inches, maurerlat, sheathing, and roofing material. The rafter system is assembled on the ground and lifted as ready-made trusses. This speeds up the work and reduces the likelihood of errors. The rafter spacing is 24 inches if the roof will be covered with metal or ongulin. If heavy shingles are used, the spacing is reduced to 16 inches. The rafters are attached to the top frame with metal brackets and nails. For additional strength, ties are installed. They prevent spreading apart. Rafters under load. After installing the rafters, the sheathing is immediately mounted. If the roof will be metal, a sparse sheathing with spacing is used. 24 to 28 inches. If it's a soft roof, a solid deck made of plywood or OSB with a thickness of at least half an inch is used. Before laying the roofing, waterproofing is mandatory. This protects the insulation and the ceiling from leaks. The roofing material is chosen considering the speed of installation. Metal tiles or corrugated sheets can be laid in one day. Flexible shingles take longer to install, but they better absorb noise from rain and wind. After the roofing, the drainage system is installed immediately. If this is not done during rain, water will flow onto the walls and the foundation, which will eventually lead to their deterioration. After completing the roofing work, you can move on to insulation and facade finishing. Insulation and protection of the frame. A frame house requires quality insulation, otherwise it will be cold in winter and too hot in summer. The interior space of the walls is filled with mineral wool, eco-wool, or polyurethane foam. The optimal thickness of the insulation is 6 inches for warm climates and 10 to 12 inches for cold regions. Before laying the insulation, a windproof membrane is secured on the outside of the walls. It prevents heat from being blown away and protects the frame from moisture. After this, the walls are sheathed with OSB or plywood panels. They provide rigidity to the structure. It's important to leave a gap between the insulation and the exterior sheathing so that moisture can evaporate freely. From the inside, the walls are covered with a vapor barrier film. It protects the insulation from moisture that forms inside the room. Mistakes at this stage lead to condensation forming inside the walls, which over time causes mold and wood rot. After insulation, you can proceed to the exterior finishing. The faster the walls are covered with facade materials, the less likely the insulation will get wet. Installation of windows and doors. After insulation and exterior sheathing, proceed immediately to the installation of windows and doors. This is important to protect the interior space of the house from precipitation and to speed up finishing work. If the openings are left open, wind and moisture will penetrate inside, which will slow down the installation of electrical systems and finishing. Window and door openings are reinforced in advance with additional studs. This prevents deformation of the structure under load. When installing windows, mounting plates or anchor bolts are used. A gap is always left between the frame and the wall for mounting foam. It compensates for the expansion and contraction of materials during temperature fluctuations. Door frames are installed strictly level. If there is any misalignment, the door will not close or will start to open on its own. The bottom threshold is treated with waterproofing to protect against moisture. After installation, all gaps around windows and doors are filled with foam and covered with slopes. Outside, window openings are fitted with drip caps to prevent rainwater from entering the wall. Once the house is completely enclosed, you can proceed with the installation of engineering communications, electrical and plumbing. Electrical wiring and water supply are installed before the start of interior finishing work. In frame houses, all communications are laid inside the walls, so the placement of outlets, switches, and plumbing nodes is planned in advance. Electrical wiring is laid in corrugated pipes or cable channels. This protects the wires from damage and reduces the risk of fire. For main outlets and lighting, wire with a cross-section of at least 12 AWG is used. For powerful appliances, 10 AWG and above, all connections are made in junction boxes, which remain accessible after finishing. Plumbing is most often done with plastic or metal plastic pipes. They do not rust and are quickly installed. Hot water pipes are additionally insulated to reduce heat loss. Sewer pipes are laid with a slope of at least 1/4 inch per foot to ensure gravity drainage. After laying all the utilities, the system is pressure tested. The electrical wiring is tested with a multimeter. The plumbing is filled with water and checked for leaks. Once the engineering systems are ready, you can proceed to the interior finishing. Rough finishing. Rough finishing includes the installation of interior partitions, wall sheathing with drywall or plywood, and the construction of floors and ceilings. The frame partitions are made from 2 by 4 inch studs spaced 16 inches apart. Sound insulation is placed inside to reduce sound transmission between rooms. For wall cladding, drywall or moisture-resistant plywood panels are used. They are attached to the frame studs with screws, and the corners are reinforced with metal angles. The floors are made from plywood that is 1 inch thick. They are laid on joists spaced 16 inches apart to prevent sagging. After this, the finished flooring can be installed. Laminate, linoleum, or parquet board. The ceiling is covered with drywall or stretched with PVC film. If the house is single-story, a hatch is left in the ceiling for access to the attic. Final finishing. The final finishing includes painting the walls, installing baseboards, and setting up lighting fixtures and plumbing. Before painting, the walls are primed, puttied, and sanded. This prevents cracks and improves the adhesion of the paint to the surface. The chosen flooring, such as laminate, vinyl, or carpet, is laid on the floor. Ceramic tiles are used in areas with high humidity. All joints and corners are covered with baseboards and moldings. Install light fixtures, outlets, and switches. Connect plumbing fixtures, sinks, toilets, and shower cabins. Check the operation of all systems and fix any possible defects. After finishing the interior, the house is completely ready for occupancy. The final stage is budgeting and analyzing mistakes that could have been avoided. Let's summarize. The cost of building a frame house depends on the area, chosen materials, and region. The main expenses include the foundation, frame, insulation, roofing, engineering networks, and finishing. The more compact and simpler the house, the cheaper it is to build. The foundation is one of the most expensive cost items. A screw pile foundation will be the cheapest option. Its cost starts at $15 per square foot. A slab foundation is more expensive, starting at $25 per square foot, but it provides better thermal insulation. A medium depth strip foundation costs from $20 per square foot, but it requires time to set. The frame of the house consists of posts, beams, binding, and flooring. The average cost of lumber for the frame is between $10 and $15 per square foot. If kiln-dried boards are used, the price increases. Insulating walls with mineral wool costs $5 to $7 per square foot. Polyurethane foam is more expensive, starting at $10. The roofing is one of the key elements, affecting the price. Metal roofing starts at $5 per square foot. Asphalt shingles start at $8, ceramic at $15. The simpler the roof shape, the cheaper its installation. Utilities are another expense item. Electrical work costs $3 to $5 per square foot. Water supply and sewage range from $5 to $10. Heating depends on the system. Electric is the cheapest, while gas and water systems are more expensive. The final finish is the last major budget item. If you use drywall and paint, the cost will be from $5 per square foot. Wood paneling or panels are more expensive, starting at $10. Laminate or linoleum flooring will cost $3 to $5 per square foot. Tile starts at $10. The total cost of such a house with an area of 800 square feet starts at $60,000 if you build it yourself, and from $100,000 if you hire contractors. With proper planning and cost optimization, you can reduce expenses without losing quality. But if mistakes are made, they can significantly increase the cost. Mistakes that can ruin everything. The main mistake when building a frame house. Incorrect choice of foundation. If the soil is not studied, the foundation may crack or shift. It is especially dangerous to use a strip foundation on clay soils without drainage. In winter, it will start to lift, and in spring, it will settle. The second common mistake is the incorrect spacing of the frame studs. If you place the studs with a spacing greater than 24 inches, the walls will start to sag, and the sheathing fasteners will weaken over time. If you don't use braces or metal brackets, the frame will lose rigidity, and the walls may become skewed. The third mistake: saving on insulation and vapor barrier. If there are gaps left in the insulation, cold bridges will form, increasing heat loss. If the vapor barrier is installed incorrectly, condensation will start to accumulate in the walls, leading to the rotting of the frame. The fourth mistake: violation of roofing installation technology. If an underlayment is not installed under the shingles or the wind bars are not secured, the roof will start to leak. If the rafter spacing is too large, the roof may sag under the weight of snow. The fifth mistake concerns windows and doors. If compensation gaps are not left, the frames will start to bind with temperature changes. If waterproofing is not used under the thresholds, moisture will start to penetrate inside and destroy the foundation. Such mistakes increase repair costs and reduce the durability of the house. They can be avoided by following the technology at each stage. Let's consider the alternatives. Frame houses are among the fastest and cheapest to build. But there are other technologies used for private home construction. They are more expensive, more complex to install, and require more time. The main alternatives are made of brick, aerated concrete, timber, and monolithic concrete. Brick houses are considered the most durable, but construction takes from several months to a year. Bricklaying is a labor-intensive process that requires precision. Brick itself is an expensive material and also requires a strong foundation because it creates a significant load on the base. The foundation for a brick house costs 2 to 3 times more than for a frame house. The walls are erected in several stages, allowing time for the mortar to set. Then they are plastered and insulated because brick itself does not retain heat well. As a result, the cost of a brick house starts at $150,000 for 800 square feet, and the construction time is from 6 months. Aerated concrete houses are cheaper than brick ones, but still more expensive and take longer to build than frame houses. Aerated concrete blocks are light and large, so the masonry goes faster, but the material is fragile and requires reinforced armoring. Aerated concrete absorbs moisture, so it must be covered with plaster or cladding. Insulation is also necessary, otherwise the walls will freeze. The cost of such a house starts at $100,000 for a similar area. And the construction time is from 3 to 4 months. Log houses are popular due to their eco-friendliness and aesthetics, but they require a long settling period. If you use regular solid timber, the house may settle for up to a year. And during this time, doors and windows will start to warp. Laminated timber reduces the settling problem, but it is more expensive. Timber is wood that requires mandatory treatment against moisture, fungus, and insects. Such houses also need insulation, as wood retains heat worse than modern insulators. The price starts at $120,000, and the construction time is from 4 months. Monolithic concrete houses are the most durable and weather-resistant, but also the most complex to build. Construction requires the installation of formwork, pouring of concrete, reinforcement, and a long time for curing. Such houses are often used for apartment buildings or large mansions. They require a professional crew and complex equipment. The price starts at $200,000, and the construction time is from half a year. Compared to these technologies, a frame house wins in terms of speed and cost. It is 2 to 3 times cheaper than brick or monolithic, and 1.5 times cheaper than aerated concrete or timber. It can be built without complex equipment and professional crews. The main drawback is less durability compared to stone houses and the need for more thorough thermal and sound insulation. But if built according to the technology, such a house can last at least 50 years. That is why frame technology remains the best choice for fast and affordable construction.